So remind me, how do we calculate concentration? Yeah, absolutely right. Concentration measures the amount of solute dissolved in a solvent. And boy, those words really, to me, are always so, I find them confusing. So recall that concentration is a measure of the amount of solute dissolved in a solvent. So typically we would say concentration equals stuff over volume, right? And that's kind of pejorative. Usually we measure that in what's our typical unit of measurement for stuff. So it doesn't have to be this. Typically we measure stuff in moles, and typically we measure the volume of the solution in liters. And another way of expressing moles per liter is, or molar big M. Big M molar means moles per liter. Good. All right. But I want to propose to you a problem. Your mother may be a problem. My mother is a saint. Anyway. Well, there you go. I don't know why you said it. These numbers are often quite small. And the example I want to use is that an acid, for example, may have a concentration of H plus equal to, I don't know, 1.5 times 10 to the negative 5 molar, or a concentration of H plus of 3.0 molar. If we put these on a graph, and if we graph these, and we're just going to sketch this, I just want you to kind of see the point. This acid, the 3.0 molar, would be up here, right? And what about this acid? Where would it be? Well, 1.5 times 10 to the negative 5 is 0.00015. What is that number basically? Sorry? I mean, it is, for all intents and purposes, it is 0. Except it's not at all meaningful that it's close to 0. Do you know what I mean? An acid that has a concentration of 1.5 times 10 to the negative 5 has a pH of 4 point something. That's a serious acid. Like that is an acid. It has acidic tendencies. But if we graph its concentration, it looks as though it's completely insignificant. Does that make sense? So this misrepresents the concentration. Does that make sense? When we have to graph really big numbers and really small numbers, the really small numbers all end up looking like they're exactly the same. If we graphed another one that was 7.0 times 10 to the negative 5 times as concentrated as that, it would look the exact same on the graph. Does that make sense? Because on a graph that goes up to 3, 0.000015 and 0.000075 look exactly the same, but they're really different numbers. Does that make sense? So this is a problem. So what's the solution to that? And the answer is power. Yes, correct. And by power, what I mean is power in the mathematical sense. In math, what is a power? Yes, very good. It is a number that includes an exponent. So let's take a look at that. So the solution the solution to working with numbers with large ranges is to use a logarithmic scale. Now, how many of you learned logarithms yet in math? Probably not too many of you, would be my guess. Anyone learned log rules yet? That's okay. As keeps happening in this stupid science curriculum, which is that they keep giving us math skills to have you use that you haven't learned yet. If you took grade 10 science first semester, then you had to use sine, cos, and tan before you'd ever learned sine, cos, and tan in math class. It sucks. Kind of stupid. Likewise, this is something you should know from math class before you have to use it in a science class. So I'm going to give you a brief little math lesson, okay? It's easy enough. You can do it, I promise. Simple stuff. Ready? Here's how it works. This is based on powers. And if you don't remember what a power is, that's okay. I'm going to tell you. If we have some number, I don't know, let's say 10 to the exponent 8. This whole thing is what we call a power. Within that, we call this number here what? The base. Very good. And we call this number up here the exponent. Good. So power is made up of a base and an exponent. And is everyone comfortable with powers? I don't need to tell you what that means. That means take the number 10 and do what with it? Perfect, great. Everyone's comfortable with that? That means times 10 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 until you have 8. Right? Cool. All right, everyone's cool with that. Okay, well, scientists express numbers as negative powers of 10. And I'm going to show you what that means. And I'm going to show you how to do the math. And it's actually not that stressful. So don't be stressed about it. Even if you're like, I'm not a math guy, and this looks scary to me, nothing to be scared of. The most common place we use this is a place I guarantee you've already seen this, so you probably didn't necessarily know what you were looking at, which is for acids. So the biggest example of this is acid strength. Which is really the concentration of H plus ions released by the acid. Is measured on what scale? Not in. On the what scale? Yeah, it's a logarithmic scale, and it's called the pH scale. And the pH scale is so called because the P stands for power, and the H in this case stands for what makes something an acid? H plus ions. And really, it's the power of 10. In fact, it's the negative power of 10 is what P stands for. The negative power of 10 of H plus ions. That's what pH scale means. It means how strong is this acid by taking the concentration of H plus ions, but expressing it as a negative power of 10. And again, if you don't know what negative power of 10 means, don't worry about it. I got it. We're going to do it together. All right? So we're going to make ourselves a little table. One year on a final chem exam, I had a question, and I said in brackets as a hint, you may want to make a table to help you with this. And a student, without me noticing, tore that page off the exam and then proceeded to do like paper origami and paper folding and stuff and turned it into a table. I gave that kid 2 out of 10 for creativity. That's great. Right? So I gave him marks for it, so that was good. I felt like that was generous of me. But he did. He made me like a really cute like folded table. I treasured it. Yeah, I kept it on my desk for a while. I wonder where that is. I probably threw it out at some point. Anyway, but he's a funny kid. Kyle Kajast. Funny guy. All right. So let's look at an example then. Let's take a look at acids, and let's look at it if we measured their strength by measuring the concentration of H plus in moles of H plus ions per liter. Right? And we'll start with nice, easy numbers to work with. So what would probably be the easiest number to work with? Well, I guess 1.0 molar would be an easy acid to make. You just have to get 1 mole of a strong acid, or 1 mole of a strong acid, and dissolve it in 1 liter. Ciao. Gotta be honest, it's not working for me. Thank you. Howdy. Thank you. So, that would be an acid. Now, what is this as a power of 10? And another word for a power of 10 is a logarithm. In other words, what that means is 10 to what exponent equals your number. Does that make sense? That's what a logarithm means. What number would I have to put the exponent 10 to get that? So if I did 1.0 molar, what do I have to put 10 to what exponent equals 1.0? 10 to what exponent equals 1? Yeah? Nope. 10 to negative 1 equals 0.1. We'll get to that later. Nope. 10 to the power of 1 is 10. Yeah.
Tiana Moody, is she in class?
Nope. No, she's not.
Okay, thank you.
No problem. It's probably a subtle hint that I should do my attendance. Don't you think? Quiet. Quiet. Quiet! Yeah, try it on your calculator. 10 to the exponent 0 equals 1. Those are our... Who said 0? Who said 0? Who said it? Don't actually throw them out. No! No! Oh my God. Guys, you have to know exponent rules. Listen, ready? Just quiet. Quiet. For God's sakes, be quiet. Look at me. Look at me. What does an exponent mean? It means multiply by this number how many times? Well, 10 to the exponent 3 means multiply by 10 3 times, which would be 10 times 10 times 10, which is 1,000. 10 to the exponent 2 would mean multiply by 10 twice. Multiply by 10, 10. Multiply by 10 again, 100. 10 to the exponent 1 would mean multiply by 10. Multiply by 10, you get 10. 10 to the exponent with 0 would mean don't multiply by 10. And if you don't, no, of course you wouldn't. Because when you're multiplying, you're not starting with 0. Because if you're multiplying and you start with 0, it doesn't matter what you multiply by, you'd always get 0. So when you're multiplying and dividing, you're never starting with 0. What's the default number in multiplying? It says 10 to the exponent 4. That really means 1 times 10 times 10 times 10 times 10, right? If you have 1 times if you have 10 to the exponent negative 6, that says divide by 10 6 times, right? But what are you dividing by 10? What goes on the top of that fraction? 1. In multiplying and dividing, the default number is always 1. So if it says 10 to the exponent 0, that means don't multiply by the number 10, and that equals 1. So this expressed that way is 0. All right? And likewise, if we did a 10 molar solution, which would be a very concentrated acid, 10 to what exponent equals 10? 10 to the exponent 1 equals 10, right? That's a better way to write that. Therefore, what is the logarithm of a 10 molar acid? 1. What if instead of being 10 molar, we wanted to make 100 molar acid? This would be I don't even think you can make 100 molar acid. Maybe you can, I don't know. That would be very concentrated. I don't know. You'd have to do some serious work to get that to dissolved. 10 to what exponent would make 100? 10 to the exponent 2 equals 100, right? So when we take the logarithm of 100, we get 2. Now, the thing of it is, we don't get high concentrations like this very often. 1 molar is a very strong acid. 10 molar is such a dangerously strong acid.
Hi, at this time, could all members of the track team and the volunteers
Have fun.
make your way down to the front foyer?
Bon chance. Oh, you're not competing, but still, good luck volunteering. May your rake be true and your... Do you know what event you're doing?
I have no... I think I might be doing hydro.
There you go. Well, may your... I don't know. May the bar stay placed properly. I loved high jump. I was never very good at high jump, but that was like my favorite field event. I was bad at long jump. High jump to me, at least, it was like long jump. I was just like I'm competing against myself and doing poorly. At least with high jump, there's like an enemy to defeat. That bar, like I'm getting over that bar.
Sand's not an enemy for long jump?
Are you about to do the Anakin? Like I hate sand.
No.
It's rough and coarse and it gets everywhere.
Think about it. You're jumping over a bar and you're jumping over sand.
Yeah, no, the sand doesn't fall down though. Like when you hit the bar, it falls down, and that feels like defeat, and that makes it your enemy. For me, I'm just describing my experience. Yours may vary. Okay, now listen. Shh. The way we calculate this on a calculator, if you can't do this in your head, because we're going to get to numbers you can't do in your head, is if you want to know this, on your calculator, you will note that there is a button that says log. So you could just take the log of 1. And what you'll find is that, do this on your calculator right now. Press log 1, and you'll find that it gives you 0. You could take the log of 10, and when you take the log of 10, you're going to find that it gives you... Bless you. So find that on your personal calculator right now. Find the log button and try all these. Bless you. Take the log of 1. It should give you 0. Take the log of 10. It should give you 1. Take the log of 100. It should give you 2. All right, so try those out. Make sure those are true. Is that true? But again, if you're wondering what that number means, what it means is what exponent would I have to put on 10 to get that number? Yes. We'll get to that in a minute. Great question. We're going to put a pin in it. Is that all right? But boy, what a good question. Okay, now let's look here. The thing is, we mostly don't deal with big exponents, right? Usually, a concentration isn't going to be 20 molar or 17 molar or 37 molar. A much more common one would actually be to go lower than this. What about 0.1 molar? What exponent do we have to put 10 to get 0.1 molar? 10 to what exponent? Well, we have to divide by 10, right, to get 0.1, right? So 10 to the exponent negative 1 would equal 0.1. And again, you don't have to have that memorized. If you can't figure that out, what can you do on your calculator to figure out what exponent of 10 gives you a number? You take the logarithm. And the log button will let you ask the calculator, hey, calculator, what exponent would I have to put 10 to get 0.1? Do that on your calculator. What do you get? -1. Good. If the concentration of your acid was 0.01 molar, what exponent would we have to put 10 to make that happen? Again, this one you can probably do in your head. 10 to what exponent equals 0.01? 10 to -2 equals 0.01. But if you can't do it in your head, no problem. Take your calculator and say log of 0.01, and it should give you -2. Can everyone try that? I don't want anyone come to me and tell me they don't know how to do this. So make sure to pick up your calculator. Log 0.01. Enter. Yeah, of course. What do we get? -2. Good. So then, that's all well and good. By the way, sometimes you're going to get not nice numbers. Really quickly, well, let's do it this way. What if my concentration was 0.00351 molar? Now, I am prepared to bet that you have no idea what exponent of 10 equals 0.00351. Does anyone know? Because I don't know, but how could we figure it out? We could take the log of 0.00351. And what's it give us? -2.45. Now try that. 10 to the exponent -2.45 should equal 0.00351. Try that. Make sure it's true. It might not round perfectly, by the way, because we're introducing some rounding here, right? Yeah, it's like 352, 353, whatever. Exponents go nuts. We'll talk about that later. When we're dealing with logarithms, you always want to keep an extra decimal till the end, because exponents change very fast. That's kind of what exponents are famous for, right? They get big really quickly. But having said that, so what is the log of this? Well, it's -2.45. Now, the thing you're going to notice is that we are very rarely going to be dealing with concentrations over 1, which means the overwhelming majority of concentrations we'd be working with, if we just took the log, we'd be getting what kind of number? Negative numbers. And so, rather than get negative numbers every time we do this, scientists don't just take the log, they take the negative log. So what they do is when we do the pH, we take the negative log of the concentration of H+, which is going to just be this same number, but negative. Now, luckily, does -0, is that any different than +0? No, but having said that, on your calculator, try this. Press the negative button, then log, and the negative log of 1, and you should get 0. Try that. Negative log of 1, you should get 0, obviously. If we take the negative log of 10 molar, we already know the answer. What's it going to be? The log was 1, so the negative log will be -1. Sorry?
I just got an error and I don't know why.
Are you using the negative button or the subtract button?
The bracket is negative.
Yeah, and then log.
Okay, I got 0. That's good.
Okay, good. That's okay.
1 first.
Yeah, that's okay. What's the negative log of 10? You should get -1. Obviously, the negative log of 100 will just be, but if you do it on your calculator, try it out. Negative log of 100 should be -2. And I'm not going to keep writing it. What will the negative log of 0.1 be? Instead of -1, it'll be positive 1. Instead of negative 2, the negative log of 0.01 molar will just be positive 2. And the negative log of 0.00351 will be positive 2.45.
Why is 100 and then 0.01, but negative 100 is negative 2? Huh?
What?
Like, why is, I don't know why I'm asking this question. Why is,
I don't know what you're asking. I'm not trying to be rude. I don't know what you're asking.
yeah, like there's a 0.01
Mhm.
is negative 2, but then.
But it's not negative 2. 0.01 is 2. Take the negative log of 0.01 and you'll get 2.
What is the negative side? Oh my gosh.
It's okay. Just try it again. We're learning this. You're allowed to not be perfect at it. It's new. We're learning it. Try it out. But make sure you get the right answer. Make sure you get the right answer. Take a minute and do it. All right? No sounds? You can make sounds, but you don't need to make sounds. You're doing great. But if the sound helps, do not let me stop you. You go nuts. All right? You're the boss of you.
When I drive, I sing the national anthem because I get scared.
Love that for you.
And like I was going down a winding road, but I didn't like how I had to turn the steering wheel to go. And my aunt's wheel is naturally crooked to be straight, and I didn't like that. So I was like, oh, Canada.
That is incredibly charming, and I love it.
And then it started raining, and I stopped the car, and I'm like, you're driving now.
My daughter and I sometimes driving try to sing the American national anthem to the tune of the Canadian national anthem or vice versa. So like, oh, say, can you see by the dawn's early light, right? And so on and so forth. Or like, oh, Canada, and so on and so forth. Anyway,
That's pretty good.
yeah.
Oh, Canada. That one sounds good like that.
It's interesting because the interval, O Canada goes up a major third, so O can, and it's the exact same interval, but the American goes down. Oh, say. So they're doing the exact same, And I think there's something nationally symbolic about that. Canadian national anthem, ascending.
No, okay, wait, no, I am confused. Okay, I just did it on the calculator, so it's not me. It could be me. 0.01, but log 0.01.
No, but you're not taking the log. You're taking the negative log
No, this is for the
of
positive
0.01.
log. And on the calculator, it gave me negative 2.
Correct. The positive log of 0.01 is negative 2.
So why are we also getting negative 2 for 100?
You're not. God. Okay, Kiki, just pause. Just listen. Reset. Look at me. Look at me. Look at me. It's fine. Because the next thing is going to do great. Ready? So this was just to kind of explain what we're looking at. You're good? Now, what to do. Ready? Here we go. Nope. Nope, you need to be quiet and focus. All right. So to find the power of whatever thing it is we're measuring in chemistry, we take the negative log of the concentration of that thing. Right? That is the formula. It's going to answer your question. All right? In the meantime, talking ourselves in circles will definitely not answer the question. So just bear with me, all right? Trust me. Okay, so let's look at an example. An NaOH solution has a concentration of OH minus ions equal to 0.0214 molar. What is the pOH of this solution? All right? The little p thing isn't just for H. We can have pOH. We can have P whatever we want. So, what is the pOH of this solution? And we'll do this one together. How do we calculate P whatever? We would say the pOH is just equal to the, what do we do? Negative. We take the negative log of the concentration of, in this case, what? OH minus. All right? That's all. And so, yeah, Kiki, if the chart's confusing you, don't worry about it, because we're never going to make a chart like that. That was just meant to make sure we all knew what logs did. This is the actual skill. So this is the important part. So now we just have to say, okay, what is the concentration of OH minus in this solution? Well, in this solution, the concentration of OH minus is there it is. Okay. So therefore, if we want to know the pOH of this solution, it would be the negative log of 0.0214 molar. And that would be -1, -2, but it's a bit bigger than that, so it's going to be 1 point something. Are we talking 1.5? 1.67? Okay. And we're in how many sig figs? You're good, right? Because I think you just gave me 3 sig figs, right? We have 3 sig figs. And so the pOH would be, what'd you say again? 1.67? 1.67. Now, another note. No units.
Why?
The unit's been built in here.
What? Oh.
When you take the pH, whether it's pH, pOH, you'll learn later on to take pKa, pKb values, you'll take pKw values, you'll take all kinds of p values. They never have units. All right? They just don't. It's a convention. It's a convention. It's the negative log of the concentration. So the concentration-y bit is built into saying that it's a pOH. For whatever reason, we do not take that. So I'm going to mention that here. Powers have no units. The name of the power tells us what we're measuring. Oh. I want to adjust the ceiling tile. There we go. Okay. That was driving me crazy. You could see inside the ceiling. That's bugging me. Anyway. All right. So, with that in mind, I kind of like it up here. Don't tell me what to do. It is nice to feel tall. Is this what Owen feels like all the time? This is incredible. I feel like I should talk like this now. All right, so we're going to look at problem 1 if everyone's okay with that. Again, I don't work for you. I definitely don't work for you. All right, I might work for Max. Do not work for you. Sorry?
I actually recommend standing on one of those people. You'd actually be able to fight. That's the one who sent me all those reels. Those were straight.
Shut up. Okay. 3.8 grams of hydrochloric acid are dissolved in water. What's the pH of the solution? I don't think so. Boy, all these ceiling tiles are like... Anyway. Oh, sorry. I need a volume. Dissolved in, let's say 2.0 liters. So it's pH. So how would you do this? We'll do the first one together. Well, the first thing to know is that if we take HCl in its gaseous form, and we dissolve it in water, we'll get HCl in its aqueous form, which really is the same as saying that we have H plus in its aqueous form and Cl minus in its aqueous form, right? Does that make sense? In other words, whatever the concentration of HCl is, that's going to be the same as the concentration of H plus. Does that make sense? Those two things should be the same. So the takeaway from this is, if we know the concentration of aqueous HCl, then we know the concentration of H plus, which is in the end what we care about, because pH is just going to be the negative log of the concentration of what? Concentration of? pH is the negative log of the concentration of H plus. Very good. So what do we get for that? What do we do? Sorry?
If that was the first floor, I think like people gotten scared.
Here we are. Did I scare you?
You actually did scare him.
I was scared for your health. I thought you were gonna like roll an ankle.
Oh God! Oh. I'm not like 80 guys. I can stand on a table for God's sake.
We're just making sure.
I'm thinking about shit. I wouldn't
No, I was
make
gonna
for
say
the
all
dogs.
these was me. I probably would have been.
I used to have, doesn't really work in this room, and I am getting older and fatter, but I used to teach in a classroom where I had lab benches like that everyone sat at. And they were a perfect distance that with just like a little hop, I could go from one to the other. So in that classroom, I used to just teach up on the desks all the time. It was kind of my thing. Oh, we don't talk about that. But I do kind of miss it. It was nice. I just felt like I was again, well, I'm going to say that my 250 pounds in fat, I think, is everything. That's fairly narrow, and that's fairly wide. And I don't know that I trust. And the other thing is, like, those are continually supported, whereas these, like, have a span, right? So, you know, and I'm not as light as I once was, so, you know.
Question: what floor do you consider like the one that we're on, first or ground?
This is ground floor.
What?
Both? I would say it's both.
I said they're
I will
the
say
same
that
thing.
is not, in my
This
mind,
is the
that
same
is
thing.
not
That's
the first
second.
floor. You can call this the first floor or the ground floor, whatever you like.
I told you.
But when people call that, like when people call the first step you go up to the first floor, I can't get behind that.
But that's how it's
Yeah.
actually labeled.
On elevators too, it's labeled.
No, it's not.
Yes, it is.
No, it goes from ground to 2. I work in a hotel, all right? I don't know about other hotels, but I can tell you in my hotel, it goes ground, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, which is hilarious, 15, 16, 17, so on and so forth. They don't have a 13th floor, yeah. Yeah. Isn't that ridiculous? It pisses me off so much. I'm like, really? We are such slaves to our stupid, like, paranoia that we can't have a 13th floor in a building.
Why can't we?
Because people are superstitious and they think it's an unlucky number.
13 is a great number.
I like 13. 13 quality number.
I thought you quit your second job and you were like
I'm laid off right now, but
laid off.
yeah.
What do you do?
I manage a restaurant.
You said you were laid off. What do you do?
No, they're renovating the restaurant.
Thank you.
You don't get laid off for doing something wrong. You get fired for doing something wrong. Do you know what layoff means? Layoff means there isn't work available.
Yeah.
Yeah. So anyway, yeah, renovating. I'm laid off. I'm going to quit when they reopen the restaurant.
Why don't you just quit now?
Oh, because I get all the because I can book a hotel room for like $20 while I'm an employee there. So that's a good deal. Like anywhere in the world, like any Hilton in the world, I can get a hotel room at cost. So that's a nice deal. And because I might go back, like this summer, I might go back 1 or 2 days a week, and then I'll quit. We'll see. Anyway, point being. Or I might just quit. All right. So how can we approach this? Well, we need to know, before we can do the pH, we need to know the concentration of H+. Well, concentration is what? Concentration of H+ will just be how much stuff divided by the the volume. So in this case, how much stuff do we have? We don't know it as we'd like it, as moles of H+, but that's okay. What stuff do we have? We have 3.8 grams of HCl. And how much liquid is that in? 2.0 liters. Problem is, I don't want to talk about grams of HCl. What can I do with that? Cool, so how do I do that? Yeah, which, Angela, what were you going to say? Feel like that better? Put grams on. Yep, beautiful. And then we'll go to you. And what that is the molar mass, which we get from where? Periodic table. Cl is 35.45. 35.45, and H is 1.01. So that should be 36.46. And that's in how many moles? 1 mole. And then we said for every 1 mole of HCl, we're going to get 1 mole of H plus, right? You can almost skip that last step, but if you're being, and then we could just do that math. And 3.8 divided by 36 should be 0.1. And then 0.1 divided by 2 should be about 0.05. 0.05-ish. Should be a little bit bigger than 0.05-ish. 0.058, 57. What do we got? 0.052. All right. 0.052. And what's the unit for that? What unit's canceled here? Grams canceled with grams. Moles of HCl canceled with moles of HCl. And that leaves us with moles of H plus per liter, which we can write as molar. Everyone comfortable with that? Yeah, there's a switch button. There's a little, I think it says change. The ones don't matter, though I think it's still a good habit to get in, because in skipping the ones, you also skip 2. But yeah, easy mistake to make, not a big deal. No problem, try it again, punch it in again. All right, now that we know the concentration of H+, how do we get the pH? So if step 1 was find the concentration of H+, given grams of HCl, step 2 is find pH. And we'd say pH is equal to what again? The negative log of the concentration of H+, which means the pH is equal to the negative log of 0.052, and that would be -2, but this is more than that, so it's going to be negative. It's going to be like 1.3, 1.2-ish, 1.28. Okay, which should equal 1.3 after the correct number of sig figs, right? And again, there's no unit. pH is a unitless scalar quantity.
I like that. These last lessons have been great.
Nice. I like this solution stuff. I had the answer here. Now, it is worth noting that sometimes you will be given a pH and asked to work with it. You can go the other way. And that's trivial. All right, it's not so bad. So, let us go to part B. Even though I didn't label the first part explicitly part A, that's okay. Who says you can't go home? We're going to go back home.
Okay, you.
You talking to me? Are you talking to me?
I'm trying to get you.
It's a literary reference, Angela. Literature.
You write so slow and bring him to the
No, instead of copying mine, why don't you do the math? Get a calculator, do the math. Right? Won't that be better practice for you? Yeah. If logarithms tell us what power of 10, in other words, what exponent 10 must be put to, to yield another number, reversing them is simple. Must be put to yield another number. It's clumsy, but it's grammatical. But it is clumsy. If I were editing this paper, I'd say, rework this sentence. Clumsy, exclamation mark. All right. So for example, what is the log of 1,000? What exponent do we have to put 10 to get the number 1,000? You can do it in your calculator. You don't have to do it in your head, but you might be able to do this one in your head. What is the log of 1,000? Sorry? 3. Okay. Now, if the log of 1,000 is 3, then, I'm going to say if log of 1,000 is 3, then that means that 10 to the exponent 3 must equal 10 to the exponent 3 must equal 1,000. Okay, good. Now that's an obvious one. If log of 254 is equal to what? Do that on your calculator. What's the log of 254? What is it? 2.4? 2.40? Good. Then, what does 10 to the exponent 2.40 have to equal? 254. Does that make sense? Therefore, to reverse a log, ten to the exponent x, right? Therefore, to reverse a power, we can say this. The concentration of whatever it is we're talking about is just 10 to the negative exponent of whatever the px of that is. 10 to the negative exponent. If you want to reverse it, if you are given pH and you want to know the concentration of H+, it's trivial. You just do 10 to the negative pH. If you're given POH and you want to know the concentration of OH, no problem. You just do 10 to the negative exponent. That undoes it. And if you understand the math of it, great. If not, this is going to be on your formula sheet. Just make sure you can plug it into a calculator and you'll be fine. Yes, ma'am. In math, we don't use decimal exponents very often because they're clumsy. Yeah, way more often they'll use fractions, but you can put a decimal in the exponent. And in science, we do it if it's convenient.
Okay, so like that's fine then.
Yeah, it's mathematically, though in a math class, they'd find it clumsy. They wouldn't like it. Okay, so let's look at an example. Not quite sure why that gets two question marks, but here we are. What is the concentration of HCl of a solution that has a pH of 6.3? And I want you to try this one yourself, but what to do is right above. This is an easy question. Easy question. All right, not meant to be tricky. One step. Before you do that, I'm going to put my tensor. I'm not going to do it on this computer, because I'm already streaming.
Okay, so you got a lot of this.
What do I do? Talk to me. Well, what we know is that pH will give us the concentration of H plus, right? The concentration of H plus should just be 10 to the exponent negative pH. Yep, which is, in this case, what? Somebody said. Yeah, very good. So in this case, we'd say if we want to know how much H plus we have, that's just 10 to the exponent negative 6.3. Very good. And that should be, the 3 of it is low, so we should be in the 5 sounds about right. So I'm going to do that in scientific notation if that's okay with everybody. So you're not wrong. That should be 5 point what? 5.0. And that should be times 10 to the negative. I always get this backwards. Times 10 to the negative 6, right? 7. Dot. See, it goes ahead. That's right. 7. Don't know why I always lose that. If you want to write that as 0.123456650, you can do that. Not how I'm going to do it. And the unit would be moles of
Oh, hold on. Why are we doing units?
H, because concentrations have a unit. What's concentration measured in? Moles per liter. And that's not quite the answer, but we've done all the math. Now the last thing you have to know is, where did the H plus come from? Yeah. So the concentration of HCl, we can assume, unless there's some other source of H plus also present, the concentration of HCl will in fact just be the concentration of H plus. Therefore, the concentration of HCl will be 5.0 times 10 to the negative 7 molar. Now, I could give you some complex question where there's 2 acids present, right? I'm not going to do that, but I could. So keep in mind that this assumption assumes there's only 1 acid present. No. Not even really. Whatever. It's a good little extension question. It's just a math trick as much as anything else. Something you should be able to figure out. And if you sat down with it, you would. I'd have to give you some hints. I have to give you information, right? But right now, I'm not at the let's be tricky stage. If everyone's cool with that, I'm kind of at the let's get the basics stage. There's a time and a place to say, hey, these tricky questions will help you extend. And in fact, I think there's a big place for that. Part of the problem is, frankly, your generation just jumps straight to Google or whatever. You don't fight. I'm serious. You don't fight with things long enough that that's a useful project anyway. Doing really, really hard questions is actually a great way to learn, but it requires a degree of stamina and stick-to-itiveness and willing to kind of suffer through something that, no offense intended, though I guess some offered, but I don't tend to see very often. There tends to be a defeatist attitude when something gets difficult, as opposed to an adventurous spirit. Which is weird to me, because I always think people aren't that way with video games. People play a video game and die over and over and over and over and over and over and over again, and they seem to not find it discouraging. Now that's because video games have been custom designed to be addictive. But you watch somebody do a sport, and they'll try that, especially they'll shoot free throws all day, right? Or they'll shoot, and then they'll go back and try a really hard 3-pointer, and they'll miss 20 in a row and keep at it, right? Or to me, the ultimate is skateboarders. You ever watch a skateboarder trying to learn a new trick? Or have you been a skateboarder trying to learn a new trick? Try and fail, 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 try and fail. Hey, I got it! Fail, 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 fail. Hey, I got it! But sometimes academically we get discouraged by failure. I don't know why. I don't know why being I don't know why failing at a difficult math problem is more discouraging than falling on a skateboard. Never saw a difficult math problem break a kid's nose. If you have, I'd be curious to know what the mechanism for that was. But I never saw a difficult math question break a kid's nose. Could you imagine if you just got, I thought you were saying adrenaline was why could you imagine like you were so pumped up for a math thing, like your nose just went like, anyway. No, I do. I think the adrenaline's a piece of it. But I think the other thing is we've been conditioned culturally to think, oh, if I get this question wrong, that means I'm stupid, or that means there's something wrong with me, right? Whereas we've been conditioned with physical things to be told, well, it just takes practice. Just do it again. Try again, right? So I think there's a lot of that's social. I think that there's like a stigma of failing academically, that there isn't a stigma to not making a 3 throw, But there shouldn't be, because the only way you learn is by failing. There's no success like failure, and failure is no success at all. Do with that what you will. So I'm going to give you a little bit of homework for practice. Oh, sorry. That's not my A question. Sorry.
A. What is the pH of A? You know what I mean?
I don't, but that's okay. Yeah, exactly right. So the concentration of H plus in this case would be what? Not 0.01 molar. The concentration of H plus, though, would just be 0.02 molar. Because for every 1 mole of H2SO4, you get how many moles of H plus? 2. So you just take this number and double it. You got it. Good. All right. Oh, I see what you're saying. Ready? Problem solved.
Okay.
I thought you were saying something about like it being after pH, and I was like, I don't understand what that means, but now I get it. That's what you're saying. That should have been a number 1, but I'm going to stick with it. I know, I'm going to save that problem for tomorrow. That's what we'll open tomorrow with. This is your homework. Granted. Granted. What are you doing?
That was stuck in her head for a while. So it fell out.
What if you'd stabbed her? You put the pointy side up.
But it was
If she'd gone like this, she could have stabbed herself. I'm not cool with that. We don't stab in this classroom.
Yeah, but you don't stab in this classroom.
Hello, welcome. He comes back from vacation, he's all stabby McGee over here. And how would you feel if I only referred to you as Stabs McGee from now on?
it's the lightest name of all.
That is a pretty white name, that's fair. So you don't quite have the complexion of a McGee.
I think that makes
The Irish not traditionally known for the rich skin tones, but listen, it's the 90s, kids. Or it was the 90s 30 years ago. Anyway.
95 years.
I don't want to think about that. No, I'm born in 83, so I was 7. I still remember being in class and coming back from the Christmas breaks, and we stopped saying, because we always did the date in French in the morning at school, and so it'd be like, il est lundi, le 2e de janvier, and then I remember having to say 1990 instead of 1989. I have a vivid childhood memory of that, of like coming back and like having to learn a new way to say the year at the end of the date every day, and like getting it wrong. Anyway, that's the end of my story. Yeah. Yep. A negative of a negative is, yep, exactly right. Yeah. So, where are you tomorrow? Oh, which we have said 38 times now.
Yeah.
So we're going to do a little lab. And if any of you has to miss it because you're achieving something in another class, just let me know. Yeah, we're doing a lab. It's simple. It's an easy one. And it's going to help you understand the stuff. You're going to achieve a simple little lab. Sorry? Yeah. No, because you know what? You're doing a lab tomorrow.
Other than the lab.
We just did a lesson. Yeah. Yeah, in the afternoon. Are you feeling peppy?
No. Oh no.
I'm feeling music.
What are you guys playing?
Happy.
Obviously.
Yeah.
Definitely your peppiest song.